Okay, so let's talk about the connection between the graphs y equals x plus 4 and y equals the square root of x plus 4. This here is a line and this here is a square root graph. So as you can see here on Desmos, f of x is equals to x plus 4 is a red line with a slope of 1. The square root of f of x is the blue line. It looks like a radical. In fact, it is. We replace f of x with x plus 4, and so you could think of this as the original radical graph, y equals sqrt, square root of x, shifted 4 units to the left. So the green graph is the square root graph shifted 4 units to the left. Now please remember that the square root of the red graph generally gets crushed down. So for example, the square root of 9 becomes a 3. And the y value, the square root of 4, becomes a 2. And as for y is 1 or 0, we call these points invariant, because the y value of the original function f of x and its square root stays the same. The square root of 1 is 1, and the square root of 0 is 0. Now, is the red graph always above the green graph? No, that's not the case. It usually is. However, the square root function actually surpasses the red graph when we're dealing with numbers between 0 and 1. So consider the square root of 9. When you look at the inside x value, generally when you take the square root of it, it becomes smaller. So the square root of 9 gets crushed down. However, there are exceptions. Think of the example 1/4. What times what becomes 1/4? And the answer, surprisingly, is 1/2. It actually goes up. So here we go down, but here we go up. And that happens to be the green part here. Okay, so for question number 37, we're looking at the connection between the graphs y equals x and y equals absolute value of x. So we see here on Desmos that y equals x, or also known as f of x equals x, is a purple line. However, when you take the absolute value, notice how we're making everything positive. What used to be -2 here gets flipped up to be +2 here. What used to be -4 here gets flipped up to be +4 here. So from now on, please memorize the absolute value of x is based off the original graph here, x. However, it all flips up to be positive, so it looks like a V. So now it's your turn. Based on what you heard, can you sketch the square root of these graphs here? So pause the video if you want to try yourself. However, if you have Desmos, try y equals the square root of f of x, which is the square root of 1 minus 2x. We know how to draw the line, but if you think about the invariant points where y equals 0 and 1, you can connect these pieces and even take the square root of 9 and drop it down lower. Take the square root of 100, it drops down to 10, etc. You can roughly sketch this graph even though you don't fully understand transformations. So later in this course, we're going to practice some more quadratics. But right now, hopefully you know that y equals x squared is a happy face, it's a parabola. And the +4 is a basic transformation. We're going to shift 4 units up. Can you point by point take the square root of the y value? The square root of 4 is 2. Y equals the square root of f of x looks like this. And you can do it point by point. The square root of 4 would be 2, the square root of 9 would be 3, the square root of 100 would be 10. So you can see that generally all these positive numbers gets crushed down to become the blue graph. So the next time you see a radical, look inside to see if you could sketch the inner function, and perhaps point by point you can draw something that you couldn't do before.